what happens behind the scenes. We are talking here about distributed databases which are meant to store terabytes of data. So if you screw up this during the table design, then no one is going to help you. Therefore, it's not only enough to create a table, but you have to understand what happens behind the scenes. And let's talk about this primary key and what happened exactly here. So why I was able to query it based on email, but I wasn't able to query it on the tweet date without full table scan. So the primary key in Cassandra, I'm not boring you or something, right? Just to really check. Because then we can skip to some details and whatever. So and you can understand. That's even better. Okay, good. So the primary key in Cassandra consists of the two parts. First part and the second part. The first part is called partition key, and the second part is called clustering key. And there is very good reason for that. Let's first talk about partition key. So if you have a table, this table distributes over many nodes in cluster. Each node in cluster is responsible for some data subset, from some range of the data. And this is a number, 128 bits number. So, and what Cassandra does, it takes a value of your email, which is an email address, generates a hash sum out of this key, and it's also a 128-bit number. And based on this number, Cassandra knows where this data set belongs, so to which host. So without knowing this first part of the primary key, Cassandra doesn't know where to look for the record, on which machine. Was it clear with this hashing mechanisms? It's quite standard hashing based. And basically you have in a simple, in the simplest deployment you have something like a ring, right? Each node in this ring is a different server, and each node is responsible for different data set. So let's say the first node is responsible for data set between 0 and 20, the other between 20 and 50, the other between 50 and 60, and the other between 60 and infinity. Now you take an email address, you generate a hash sum out of this email address, and it gives you 70. So you know that that's the second node. So every client in Cassandra cluster knows actually the topology of the cluster. And therefore it automatically knows where this record belongs. Which means without knowing this first part of the primary key, Cassandra can't know where to store the data. That's why we were able to query it by providing only the tweet date.
So does every primary key always have exactly two parts?
No, you can have also only one part. I mean, without this part.
And more than two?
Yes, I mean, each primary key has two parts. But now you can put a brackets here and here, and you can create something like a compound keys. Compound keys, right? Like you could sort your data by tweet date and the first name, and I don't know the size of his pens and so on, one after the other. Then you would create a compound key. So you can add those keys. This is the simplest example.
So, but each key has like a part that describes where it goes to, which node it goes to, the partition part, and clustering part, which is more or less for the sorting.
Exactly. So that's why this is called what was the name? I put it in here. Partitioning key. It's already late. That's why this is called the partitioning key, because it shows you the partition, and this is called clustering key because it tells Cassandra how to organize data on the file system. And this is what we are going to talk right now about, because this is actually quite important that the background is fantastic, I see that you will understand how to design your tables.
What do you mean by Cassandra client? You said every Cassandra client knows where the data is stored.
I mean, they know it based on this key, so every Cassandra node, actually not the client, but every Cassandra node knows the full cluster topology. So the Cassandra cluster is exchanging the data between nodes or using a gossip protocol, which means every node is equal and every node knows everything about other nodes, inclusive cluster topology. Okay, so we have our email address, which leads us to concrete cluster and to row. This should be a long table, but it doesn't fit on the screen, so I broke it here, but you can imagine that I would go further.
Sorry, I have one more question. But the query is then directed to any arbitrary node in the cluster, right?
Exactly.
Okay, and this node where I direct the query to is responsible for answering it. So either the data is on this node or it gets it from another node.
Exactly. So what the client does, it chooses the nodes by random robin or round robin. You can configure it. It chooses any node, and now from now on, this node becomes coordinator. And now this node is responsible to propagate data where it belongs. Or you can use Astyanax client, and it will contact directly to the right node, which means that you can save one network operation in that case. Maybe the latest Cassandra client does it too. I didn't check it actually. I'm not sure. So we have our email address, which leads us to concrete server, and now on the server we have our table. Now maybe you heard this term that Cassandra supports wide rows, which would mean that this is a row containing millions of columns, or even the larger number. I don't know how many bits is that. It's an integer. So, but so far we have seen actually like 2 columns and 2 parts of primary key, and this is already a wide row, because I have provided the second parameter, which is a tweet date, which makes of the normal row with 2 columns actually a wide row. So this is something what happens behind the scenes, so you won't see when you execute the queries, but you should understand how it works below the scenes. Let's take a look at this example. So this is how Cassandra would store tweets by date in its internal structure for one single row. This is one single row for the user freedom. So this is the first tweet, this is the second tweet, and this is the third tweet. What Cassandra does, it takes this argument, which is in our case tweet date, and prepends it to each column. So we will see tweet date icon, tweet date text, tweet date icon, tweet date text, tweet date icon, tweet date text. So the fact that those columns are lying together, from Cassandra perspective, it's like, let's say, coincidence. They are lying together because they are together grouped by the same criteria. So physically on the SS table structure, so in the Cassandra, you will have such a structure like this one. So when you are reading tweets for this user, Cassandra will go over those records. Exactly in that order. Is that clear with this prepending stuff and so on? And now, for example, we have tweets by date, and we would leave out this part, so ordered part, yeah? So you would have to specify the order in each query. So the tweets wouldn't be sorted in the way that you need it for the query. We will sort it by normal date, so it means the latest tweet would be on the end of this row. And you would like to normally first read the latest tweets. In SS tables, so in this structure with Cassandra have, there is no something like end of SS table. There's beginning, but there is no end, which means jumping on the end of SS table, it's not very efficient. I mean, you won't kill the cluster, but you might need a few disk seats for that. So, and if you have some crazy user who has like millions of tweets, then maybe you would like to have the performance way, so you would need to sort it in the right way. This is something that you don't care when you have normal database. You don't care for it. You can just sort it in any way, it doesn't matter. You can change the index later on. You can't change this structure here in Cassandra. Once it's done, it's done. Cassandra data structure is immutable, you can't change it. So it's important to understand how it works behind the scenes, because then you can create a model which works in a performant way. Okay, I have one more example, then we are through. Any more questions to that?
So if you insert another tweet, it will stay sorted and it will not be appended in the end.
It will be appended at the beginning. I mean, yeah, at the beginning. I mean, because
This is the latest tweet.
This is the latest tweet. So what Cassandra does is, I'm not sure if I should go into it because it's not a single file what you have there, but those are many small files which are called SS tables. And the older files, let's say they are lying somewhere there, no one cares about them. So the recent files, so those hot files are easier to access. So what Cassandra does, it takes your write requests, and once memory is full, it flashes it on the disk in a form of SS table, which means that the latest SS tables are containing also the latest entries. So it's easier to append in the beginning than on the end.
Okay, I mean, but these columns, are they sorted by the tweet date?
Yes.
It's always sorted, right?
Yeah, so
It's always
if I add a tweet, not in the end, but I don't know, in the days between, it will be...
Exactly between, yes, that's completely not a problem. What Cassandra does, it dumps a memory, which is held already in form of SS table on the hard drive. And once you query the data, it will fetch different files and merge sort them. So the write performance is very fast because it just flushes the memory of it. It's like an append. It has to do some work when it reads it, but actually also not much, and especially if you are reading the hot data, then even less. It's still merge sort, but most informations that are required for that are anyway in memory, so it's actually very efficient. So it's actually more like, yeah. There are many small files that you have to merge when you read the data. I mean, small files, I mean, you can compute them, it could be like 60 megabytes per file, which is small. Any more question about this one? Because this was actually the most important part of the whole talk.
So if
To have the understanding of this stuff.
So if you have a use case, your use case implies in a query, and if your use case changes, you have to change the query, and that implies that you have to change the table.
You can't change your table, but you will have to create probably a new one.
Okay,
You can alter the table, of course, but in some limited ways.
Okay, so you create a new table and you have to migrate the old data into the new table structure.
Yes.
Okay.
Which you can take. Well, actually, it's not a difficult task for it, so there are tools that can help you with that. So, but you have to do it.
Okay.
So it's not for free.
Mm-hmm.
Because as you can see, there are actually limited ways how you can query this table. If you will have time, I can also tell you something about secondary indexes, which might help you a little bit, but you won't get far. So you have to actually do what you said.
Is there a limit on the number of columns?
It's integer. 32-bit? 32-bit. Don't know the number. 32-bit.
Have you worked with statements that are that rows are that wide?
No, 32-bit like few millions.
So up to a few millions. You went up to a few million columns per row. Any performance loss?
No. I mean, I remember when we installed our first Cassandra setup, then we had a monitoring, and then the alarm rised because we saw like, okay, this insert takes like 2 seconds, what is happening, and then we figured out that actually the time that we are measuring is in nanoseconds, and not in milliseconds. So we had insert times of like a half millisecond or so, having like millions of customers. So it's extremely fast, but assuming that you are doing your things right, so I mean, you can screw up every database, but if once your model is right, then it's extremely fast. I mean, the Netflix is using Cassandra, and they have like 100 nodes in cluster, and it performs also well. But I have also tried with gigabytes of data and millions of entries, and the only problem was actually the Java code, which was slower than the database.
But I mean, it was really the number of columns, not the number of rows.
Number of columns, yes. So millions wasn't a problem. I didn't have use case for more. Yeah, because I can't go deeply, but Cassandra actually doesn't care whether those are 5 or 5 millions. I mean, if you have enough memory, and then it makes no difference whether you read 5 rows on one which is wider. It's meant actually to have wide rows. That's the idea behind it. Questions now? Should we go further? Okay, I have one more example. Oh,
Yes, you have written those client for Cassandra, and what was your biggest struggle to deal with Cassandra? Or to,
I worked few, I forgot to say it. Because I worked few years with Cassandra, and you would like to know the reason for that client. Maybe okay, so the main reason was it's a web application, you can deploy it anywhere, and you have easy access to your database.
Mm-hmm.
Because depends on company policy, you won't get a connection to your database because it's in some separate network, and even if you have connection today to this database, then you won't have it tomorrow, and once you have a problem, the first thing that you need to do is find out how to connect to my database. And the web application is something that every company can deploy and they know how to manage it.
Mm-hmm.
So once you have it running, you have simple access to database. So the idea was simply for the developers who like to look into the database to provide easy access. And I wanted to see how the wicket is working, so actually that's a good idea. Okay, now, you remember this stuff already? Now we are going to select all tweets. We'll go very quickly over this. We are going to select all tweets which are followed by Olmo, I think. Right. So the Olmo is following Frido, you can see here, Frido and Virgul. Once he logs into the system, he would like to see the latest tweets. And obviously we need a new table for that, because there is no way that you can answer it with this old table without executing like tons of the queries and you will kill your database. So you need to denormalize your model and you need a new table, which would look like this. No, this would be the SQL statement, which is a simple intergen over two tables. So users and followers and tweets. On primary foreign key, you know this stuff. Where email, Olmo, order by, tweet date. So not much to say about it. Let's go into Cassandra. This is obvious, right? We call it tweets by subscription. Yeah. And we have email address, which is part of primary key. Actually, the primary key is the same as the previous one. So, okay. Then we have author, icon, tweet date, and text. So as you can see, we have to replicate the data. So when the user creates a tweet right now, then you would need to actually two things. First, you would need to figure out which users are following him. For that, you would need probably another table. And then you would need to insert into all those follower tables this tweet, which, so for example, if the particular user is being followed by 500 people, then you would need to execute 500 inserts in our model. Because we are creating a dedicated table for each follower, so that each follower can see the tweets that he followed. Okay, so this is the data replication. This is actually quite a lot, you might think. Now you have to think about the trade-offs. Because once writing Cassandra are very fast, and Cassandra can execute writes for you asynchronous. So you can take those 500 insets, execute them, and then don't wait for the result. It will propagate later on, which is actually fine because the person which creates a tweet doesn't want to wait until it propagates for some other guys. So you execute it, it works in the background, and it's there. Now you have replicated these tweets 10,000 times, which sounds strange maybe at the beginning. But then again, you have to see your real use case. And your real use case in that case is, once I log in into the system, I would like to immediately see the tweets that I'm following. And you have dedicated table new for this purpose, which means the query will be very fast because the data is already in the form that you would like to query. And if it's too slow, then you can buy 20 other hosts and you scale up, because those two tables are not related. So you can have only one cluster dedicated to people who are reading tweets by subscription. And it's independent from all other stuff. So this is the way how you can scale up horizontally. because those tables that do not interfere. So you don't have to, if in a traditional database, if you have one person and it has 10,000 followers, then it would mean that once those 10,000 guys are online, they will go all on the same table and on the same rows in the same table. This wouldn't scale up horizontally. This solution does scale. But you have to pay for that once you insert the data. You have to insert 10,000 records, I mean, no, a few thousand records, but it's actually not a big deal. The database is meant for that. So. Well.
I'm sorry, but now you also have to update the table as soon as you follow new persons, right? Or as you stop following persons. Not only with new tweets, you need to update the data, but also keep track of the following.
Yes, you have to come up with a solution for that too. I don't know, Hadoop or something else. So it won't get easier. Once the requirements are changing or they are getting complicated, this will get actually more difficult. But you would have the same problem with Mongo as well, so it's not a different case. So, but yes, then you need a solution for it which would be free in a traditional database. Let's say you would have to develop something which is maybe not trivial. But you could execute like a Hadoop job which is simply removing all those things, so something like that. You can first remove them on the client so that he has an impression that you have removed it, and then in the background or something like that. You can see it actually in this client how it's working. There's not much to say, it's nothing interesting, but let's see how it's working. Where is it? This another tweet. Where is this button here? There's something called resolution. Tweet by subscription. Wait a second, I will try to organize it so we can see it. Okay. As you would expect, email, tweet date, grouped by email, which is in a way the same person because we have only one guy that was following two others. And that's true, he does it. So you can see this email of the guy who is following, Not much to say. So we have replicated the data. We have the same text here as we had in the other table. We have the same email, the same icon, and so on and so on. Who cares? It scales up horizontally. You have to just live with that. So the hardware are cheap and the servers are cheap, and the data replication is the solution to bottlenecks on traditional databases. We theoretically could have also a few minutes. Is the question, would you like to hear something about secondary indexes in Cassandra or not?
Yes.
Yeah. Okay. Good. So, there are secondary indexes in Cassandra. I never used them because we didn't find use case for it, but I know more or less how they work. Because as it turns out, if you are going to develop a dedicated table, that it will be better than any index. And if you have time for it, and we had time, we have to have time because we have a lot of data, then you can develop dedicated tables for it. But let's talk about those secondary indexes. So first of all, Cassandra secondary indexes are head indexes. So that means when you execute a query on the index, then you have to know exact value. So there is no range queries on index. This is the first thing. Now let's talk about this, how the indexes are stored physically on the servers. So when you have your table and it spreads over like 10 different servers, then each of those 10 different servers is responsible for some data subset, right? And it holds also index for this data, exactly like Mongo does. So you have 10 nodes, and each of those 10 nodes holds index for the data that it has. What that means once the client is executing a query based on some index, it has to go to all those 10 nodes and ask each of those nodes, give me the results matching to this index. and then the client has to merge those results. And you have to be careful when you are using those secondary indexes because they can limit your horizontal scalability. So if you have values with low cardinality, which do not repeat very often, then that would be a good candidate for index. So for example, in our case, icon does not repeat very often. We have like, imagine we have like 10 million tweets and 50 different icons. But the tweet date is something with high cardinality. So putting an index on the tweet date or email address would be actually an anti-pattern for an index. What's the reason for that? So every time when you execute an index query, Cassandra has to blindly go on all those 10 nodes and see whether the data is there or not. It can't know it up front because how should it know it? And now if you are executing an index query on the icon, then it will again go on those 10 nodes. But there is very high probability that each of those 10 nodes will have some data matching your criteria. So each of the tweets will have, each of the nodes will hold probably tweets with happy icon. So this is actually kind of good trade-off. You're going on those 10 nodes, but each of those 10 nodes is giving back you some data, so actually you didn't waste the resources. Now, if you would put index of something which is rather unique, then you would go on those 10 nodes, but maybe 2 only will respond with the data. So that would be an anti-pattern, and it's also officially written in Cassandra documentation. So once you have an index on unique values, and you have like 10 nodes in a cluster, and it's getting slow, then what you would do, you would add another 10 nodes. It actually will get slower, because now it would have to go on 20 nodes, and will receive anyway the response only from 2 nodes. So adding more nodes in the system won't solve your problem. What would solve your problem is simply to create another dedicated table. So now, depends on your use case. You can put an index tree on things with low cardinality or in high cardinality. It doesn't matter for write performance, it would matter simply for query performance. So you can ask yourself the questions whether I would like to use index, maybe I would like to use Hadoop and MapReduce to find the data, because if you understand it right, if I understand it right now, those index query would return large amount of data. So you can solve this problem differently. There are definitely very good use cases for use indexes. But maybe it will be Hadoop, I don't know.
So if you want to use Hadoop for querying data stored in your Cassandra cluster, do you have to then duplicate the data and stream them to an HDFS cluster, or?
No, actually, you can directly connect to Cassandra, and the Hadoop has, you don't need this distributed file system, because MapReduce actually is collecting the data from some nodes. Those are Cassandra nodes. Then what it does, it stores in the internal file system. This is the map function. So if you query like 10 nodes, right? Each of these 10 nodes have this Hadoop daemon. So this Hadoop daemon will query the local node, write the results into the file system, and then set this result to the central into the local file system on the hard drive, so not Hadoop. So this is the idea behind those Hadoop queries is that each query is more like idempotent. So which means when you execute the query twice, it should return the same results, which means losing the data actually doesn't matter. You can retry the query. So there's no reason to replicate the results of the reduce on the single node, because once it's gone, you can simply retry it again and get the results again. There's a Hadoop integration in Cassandra, which is quite simple, but if you get this data stakes enterprise, which most of the companies are getting, because once you start production, you would like this one, and so on, then you have quite nice Hadoop integration with the graphical interface and stuff like that. I never tried it, but I tried the simple integration, it worked fine.
Try the open source version.
Yes. Okay, I'm not going to type it, but you can believe me. Once you create index or icon, you can verify the icon, and it returns only happy JPEG. Okay, thank you.